All right, welcome back everyone. Today we're going to be talking about solving general linear equations. As I mentioned in the past few videos, in most cases what we're going to want to do is work in the reverse of order of operations. Sometimes that won't be the case, but most of the time to isolate the variable, we're going to work backwards in terms of order of operations from what we do normally. Okay, so let's start going through these. Okay, so we have d is equal to the quantity 3d minus 12 over 6. If it helps you to visualize, we can think about this as being written so essentially that divided by 6 applies to that entire expression. So what we're going to want to do is we're going to want to multiply by 6 on both sides to cancel it over here. So that we'd be left with 6d is equal to 3d minus 12. Now we can see that we have the same variable on each side. So what we're going to want to, when you have a case like that, you're going to want to combine like terms to be able to solve. So you only have the variable occurring once on one side of the equal sign. In this case, we don't end up with a negative in front of the variable. I'm going to subtract 3d because this would cancel over here. 6d minus 3d is 3d. And then we have that equal to negative 12. Now, what we need to do on both, since we have a 3 being multiplied, I'm going to continue this over here. We have 3d is equal to negative 12. That's the same as 3 times d is equal to negative 12. So I'm going to divide by 3 on both sides. Cancel, because 3 divided by 3 is 1. So we just have 1d, which is what we need. And negative 12 over 3 is negative 4. And it works just fine that way. Okay, another way you could do this, if you wanted to do it a different way, is think about this as saying if the whole quantity 3d minus 12 is being divided by 6, that means that each term in that quantity is being divided by 6. So we'd have d is equal to 3d over 6 minus 12 over 6. So what we'd have then is d equals 1/2 d minus 2. Now we're left in a really similar situation where we have the variable on both sides, and we'd want to either add or subtract or to combine like terms so that the variable is only on one side. Again, to avoid a negative, since we have 1d on the left side and 1/2 d, which is smaller, it's because 1/2 is less than 1, I'm going to subtract this 1/2 d from both sides. So then it would cancel over here. And 1d minus 1/2 d is positive 1/2 d is equal to negative 2. So then in order to get rid of this fraction, we're going to multiply by the reciprocal, which is 2 over 1, which would cancel it. And then multiply by 2 over 1 over here. So once again, we're left with d is equal to negative 4. You can do it either way that you like. It works both ways. This first way, though, is just a little bit fewer steps. But either way you want to think about it, it works. Okay, so now we have 3 times 3q minus 4 is equal to negative 5 times 2q plus 1. Okay, so this one is kind of similar to the last one in the sense that we have something happening next to next to the expression, or next to an expression that's in parentheses. And I know that I said that in most cases we're going to go in the reverse of the order of operations, and we still will in this case. But what I'd recommend to do at first, since it's going to get really messy if you try to account for the parentheses last, is carry out the multiplication that's being done first, and then add and subtract to solve from there. So we can distribute this 3 and this -5. So 3 times 3q would give us 9q. And then 3 times -4 is -12. And then we have that equal to -5 times 2q would be -10q. Then -5 times +1 is -5. Okay, so now what we can do is we can combine like terms. So to start doing that first, I'm going to start with a variable. I want to get the variable on one side, and if we can, I'd like to not make it negative, or not have the result be negative. So I'm going to add 10q to both sides, because that gets rid of this negative, and 9q plus 10q is 19q. And then we still have the -12 is equal to -5. So now, to continue to isolate the variable and combine like terms, I'm going to add 12 to both sides, and then we'll continue on up here. So that 12 goes away on the left-hand side, so we're left with 19q on the left-hand side, and then -5 plus 12 is equal to +7. Now all we see left is that 19 is being multiplied to q, so we just have to divide by 19 on both sides. Those cancel, and then we get q is equal to 7/19, and that would be our final answer. My goodness. I'm going to throw hands with this computer in a minute. It is not happy with this video for some reason. Okay, so now we have 2/5 u plus 3 is equal to u minus 1/2. Okay, so we're in a similar situation that we were in the last, at that one point in the last problem, where we have variables and numbers on both sides. But we have the same variable on both sides, so we want to combine like terms again. And we can think about this to make it a little bit easier is 2/5 u plus 3. On the right-hand side, we have 1u minus 12, but 1 in terms of fifths would be 5/5. So we have 5/5 u minus 1/2. So to start, I want to combine the variables, or combine the terms with u, because they're like terms. 5/5 is more than 2/5, so to keep the variable positive, I'm going to subtract 2/5 u from both sides. And then we'll have 3 is equal to 5/5 minus 2/5 is just 3/5. And then we have minus 1/2. Okay, so now we, to continue on, we need to we need to add that 1/2 to get it away from the variable. Now, if we think about this, we have 3, but 3 in terms of halves would be 6/2, just to give us a common denominator, is equal to 3/5 u minus 1/2. Okay, so now I'm going to add 1/2 to both sides. Those would cancel. 6/2 plus 1/2 is 7/2. And then we have that equal to 3/5 times u. Well, like I said in previous videos, and just what you do when you have a fraction being multiplied to a variable, to get rid of that fraction, we can multiply by its reciprocal, which is just the denominator over the numerator. It's essentially the reverse of that fraction. So if we multiply these two, they'd be equal to 1. And then we also have to multiply by the reciprocal on the other side. Now we can't cross cancel it all here. There aren't very pretty numbers to work with that nothing will cross cancel at all. So we can just multiply straight across. 5 times 7 is 35, and then 3 times 2 is 6. So we have 35 over 6 is equal to u. And that was, now we solved for that variable. All right, we're getting there now. Okay, so now here is an example where you could choose to get rid of or to distribute first, but you don't have to. If you did distribute first, you'd end up with a pretty large number, but like I said, you don't have to. I'll show you two different ways that you can do this. That would give you the same answer. Okay. So method number 1, if we start with 26 times the quantity a minus 19 equals 0, if you notice, if we were to go in the reverse of order of operations, and it would be good to do that in this case where we solve for what's in parentheses last, or we account for the parentheses last, because there's no sets of parentheses on the other side. It's just 0. So what we can do is we can divide both sides by 26, because the expression in parentheses that contains the variable is being multiplied by 26. So we want to divide by 26 to get rid of it. 0 divided by 26 is going to be 0. So you're going to be left with a minus 19 equals 0. So then we're going to have, to get rid of, or to solve for a, all we have to do then is add 19. So we're left with a is equal to 19. Okay, and then a second way to do this, and I'm gonna erase this from the last one just so I have a little bit more room. We have 26 times a minus 19 is equal to 0. What we can do first instead is to distribute this 26 in. I don't know what that is off the top of my head, but let me check. Is 494. So we'd have 26 times a is 26a, and then 26 times negative 19 would be negative 494. That's equal to 0. So we'd have 26a is equal to 494. And then since 26 is being multiplied to a, we divide by 26 on both sides. And we know that since 26 times 19 was 494, we're dividing by 26 again. We should end up with a is equal to 19. Like I said, it'll work either way you do it. This one's just less steps, because essentially what this expression says, 26 times the quantity a minus 19, is that 26 was factored out from that expression. So we can divide it to get rid of it. And it would work just the same. Now we have to solve for x. We have we have 4 times the quantity ab minus 3 is equal to 2x plus 4ab. Okay, so we see that we only have x on one side. So what I'm going to do first is subtract this 4ab from both sides. So that goes away. So then we're left with 4 times ab minus 3 is equal to 2. Oh, I'm sorry. Nope, that's not right. Four times ab, ooh, I still need to subtract this too. 4 times ab minus 3 minus 4ab is equal to 2x. So now what I'm going to do is multiply or distribute this 4 so that I can see if I can cancel any like terms. So we'd have 4ab minus 12 minus 4ab is equal to 2x. Well, 4ab minus 4ab, those would cancel. So we have negative 12 is equal to 2x. So now all that we have to do is divide by 2 on both sides. So divided by 2, divided by 2. This would go away. So we'd have x over here, and then 12 divided by 2 is negative 6. And that would be the end for that one. Okay, so now we have 3s minus 2s over 5s is equal to 1/6. Okay, so there's a lot to unpack in this one, but that's fine. We can do that for sure. So we have 3s. Oh, no, not 3s, just 3. So we have 3 minus 2s over 5s is equal to 1/6. Okay, so the first thing that I'd probably do here, since we can see that there's a variable in the denominator, is clear that out. So to do that, I'm going to multiply both sides by 5s, because that would get rid of it here. So that we have 3 minus 2s is equal to 5s over 6. And just for the sake of knowing, this expression goes or is together. So we're going to keep that together. And for the sake of not having to deal with fractions, I'm going to multiply by 6 on both sides to get rid of the fraction on the right-hand side. So we're just left with 5s. And the reason I put this in parentheses is to demonstrate that you need to distribute this 6 to both of these terms on this side, because you're multiplying it to the entire left-hand side, not just the one term. So now we have 6 times 3 is 18. 6 times negative 2s is negative 12s. And now we have that equal to 5s. Okay, and now we just need to combine like terms. The only like terms we have to combine are the terms with s. To keep things positive, I'm going to add 12s to both sides. Cancel. So then we have 18 is equal to 5s plus 12s is 17s. And then the only thing we have left to do, since 17 is being multiplied to s, we just have to divide by 17 so that we have s is equal to 18/17. Okay. We have a similar situation for the next one. It's almost an identical problem, just without the fraction. So what I'm going to do first is I'm going to multiply both sides by negative 4x to clear it out of the denominator. So that we have the quantity 5x plus 14 is equal to negative 3 times negative 4x would be a positive 12x. Now, we don't have to multiply or divide by anything else in terms of the left-hand side, so we can drop the parentheses. We just have 5x plus 14 is 12x. And now we need to combine our like terms. The only like terms to combine are the terms of the variable. So I'm going to keep things positive, I'm going to subtract 5x from both sides. Those would cancel. So we are left with 14 is equal to 12x minus 5x is 7x. And then since 7 is being multiplied to the x, we need to divide it to get rid of it on both sides. So now we are left with x is equal to 14 over 7, which is 2. The only reason there was an extra step in the last problem is because we were multiplying that denominator to a fraction. So we'd had to multiply again to undo that fraction, but we didn't have to in this case. Okay, now we have 1/2 times the quantity 2p minus 4/5 minus 3/5. Okay, so in this case, we do want to work almost entirely in the reverse of order of operations, because the variable is included in this quantity in parentheses, and something's being subtracted from that quantity and multiplied to it. And rather than distribute and combine like terms, we can isolate that quantity first, then we're able to drop the parentheses and solve from there. And I can show you both ways to do it. So the first way, we have 1/2 times 2p minus 4/5 minus 3/5 is equal to 1. So if I add 3/5 to both sides, we're left with 1/2 times 2p minus 4/5 is equal to, we know that 1 is 5/5, so 5/5 plus 3/5 is 8/5. And then in order to clear this 1/2, we can multiply by 2 on both sides. So that we're left with we're left with 2p minus 4/5 is equal to 16/5. And then we have to add 4/5 to get it away from our variable. So we're left with 2p is equal to 16/5 plus 4/5 is 20/5, but 20 divided by 5 is just 4, so that's equal to 4. We can divide by 2, since it's being multiplied to the p, to cancel it, so then we get p is equal to 2. A second way to do that, potentially, if you prefer, is if you had 1/2 times 2p minus 4/5 minus 3/5 equals 1, is to distribute this 1/2 first. 1/2 times 2p is just p. 1/2 times negative 4/5, well, you're multiplying across the denominator, so it'd be, but since you're multiplying them, you can cross cancel. And the 2 factors into 4, so you'd have this 2 factors into 4, so you'd have 1, and this would become 2. So it would become 2/5. Minus 3/5 equals 1. And then negative 2/5 minus 3/5 is negative 5/5. So that's 1. So you have p minus 1 equals 1. And then you can add 1 to both sides to get p equals 2. Same both ways. It's just two different ways to think about it. Okay, so we have 16 times the quantity k plus 23 equals 0. Excuse me. And in this case, since we have just one number on the right-hand side, rather than distributing, it would probably make more sense, since there's only one number on the other side, and there's nothing being subtracted from that, added or subtracted from that quantity in parentheses. It would make sense to just try to get that, or to clear that multiplication and division away. So since we're multiplying by this fraction, to get rid of it, we need to multiply by its reciprocal on both sides. That would cancel it over here. That and 0 times anything is 0. So all we're left with is k plus 23 equals 0. So k would then equal negative 23, because you'd have to subtract the 23 from both sides. And the reason I chose to do that this way here is because if you notice, we're only multiplying something to this quantity k plus 23. So it's really easy to just multiply by the reciprocal and or divide it away to get this quantity by itself, and then just subtract. Whereas in number 8, if you notice, something's being subtracted from this quantity in parentheses and multiplied to it. So the reason I chose to pursue this avenue is so we could get this quantity by itself, so that we could drop the parentheses. And that's what I did here as well. I just got this quantity by itself so we could drop the parentheses. You can choose to do it the other way too, where you distribute first in any case when you have something like this. It's just try to evaluate what would be easier. Do you want to deal with that nasty fraction of negative 16/7 being distributed, or would you rather just get rid of it when if you can? So that's why I chose to do it that way. All right, home stretch. We have 2 problems left. Okay. So we have 2 minus 3 times the quantity 3x plus 2 equals 5 times the quantity x plus 2 plus 12. All right, in this case, it would make more sense if we distributed first, just because we have the variables on both sides. So we want to get rid of them, and we can't really divide those quantities in parentheses by each other. So we want to just have distribute and combine like terms. So we're going to distribute this negative 3 rather, and distribute the 5. So we have 2. Negative 3 times 3x would be negative 9x. Negative 3 times 2 is negative 6. 5 times x is just 5x. And then 5 times 2 is 10. And then we have plus 12. So now we can combine as many like terms as we can on each side. 2 minus 6 on the left side would give us negative 4. So we'd have negative 9x minus 4 is equal to 5x plus 10 plus 12. So we'd have 5x plus 22. Now, to avoid having any negative numbers in front of the variables, I'm going to add 9x to both sides. So we have negative 4. 5x plus 9x is 14x, and then we have plus 22. So to isolate the variable, we have to subtract 22 from both sides. Negative 4 minus 22 is negative 26. Move this over here. So we'd have negative 26 equals 14x. Now all we have left to do is divide both sides by 14. That would cancel. X is left alone on this side. And then negative 26 divided by 14 doesn't give us a nice whole number, but we can simplify this fraction. Excuse me. So, that has a common factor of 2, which would be 13. So it would be negative 13 over 7 if we got that common factor of 2 out to simplify it. Okay, so then we'd have negative 13 over 2. I'm sorry, negative 13 sevenths. It shouldn't be over 2. It should be negative 13 over 7. Okay. Last one. Also, it's worth noting, unless otherwise stated to round off to a certain value, you'd probably want to just leave the answer as an improper fraction if that's what you end up with, because it's more accurate that way, unless specifically asked to do otherwise. Okay, so we have to solve for z, and there's multiple variables, but just know that we're solving for z, so you can treat those variables just like other numbers in the equation. Okay, so same type of setup like we had last time. I'm gonna distribute those numbers into the terms and parentheses first, just so that we can combine like terms and make it easier to solve. So that would get distributed, that negative 2 would get distributed, and then this 3 would get distributed. So what we'd end up with is negative 2 times 3z is negative 6z. Negative 2 times negative L is positive 2L. Then we have plus 4L still. And then we're left with this L, and then 3 times 2L. I'm sorry, yeah, 3 times 2L is 6L. And 3 times negative 4z is negative 12z. Now we can work on combining like terms. So we have negative 6z, 2L plus 4L would be plus 6L. And then we have 1L plus 6L, which would give us 7L minus 12z. Okay, so I want to get the variable the variable of interest, the z, on one side, and to avoid having a negative in front of it, I'm going to add 12z to both sides to get rid of the negative. You can do it in either direction, you'll get the same answer. I like to do it to where we don't have to deal with the negative with the variable. So negative 6 plus 12 would be positive 6z plus 6L is equal to 7L. Now the only thing, to continue to isolate the variable, we need to get rid of that 6L that's next to the 6z that's being added to it. So we're going to subtract 6L on both sides, so that we're left with 6z is equal to just 1L. And now 6 is being multiplied to z, so we just have to divide. So we're left with z is equal to L over 6. Or 1/6 times L, however you prefer to visualize. All right, and that is it for us for this video. I hope that it helped, and I will talk to you all for the next one.